Hello, and welcome to our session on the passive house potential in the Biolab building boom. Thank you for that alliteration, Ken. We appreciate that. We're going to talk about an area that is generating a lot of interest. It's also a bit gnarly. So we're going to get after not only the opportunities, but also the challenges as we think about passive house in a really unique building type. I'm excited about the panel that we put together today, and I'm going to introduce you to our esteemed panelists. Wolfgang Hasper is with the Passive House Institute in Germany, and he's conducted his work on many lab projects, of which 3 were built and pilot certified, and Wolfgang's going to tell us about those. Apart from that, he spends his time on passive house project consulting, commissioning, and the performance monitoring of large passive house buildings. Wolfgang believes that finding suitable building services concepts is as important as getting them to perform as intended. Amen and hallelujah. Wolfgang prefers to keep systems simple and open, particularly in the field of building automation, where there is currently much to be desired, as Wolfgang would say. So welcome, Wolfgang. Blake Jackson, AIA, is the Northeast Sustainability Design Leader with Stantec in Boston. He works at the nexus of sustainability, wellness, and resiliency, serving as company-wide resources for projects seeking measurable carbon reductions and third-party certifications. Blake holds a master's in sustainable environmental design from the AA Graduate School in London. He's an author, speaker, and educator, recently serving as Vice President of Advocacy for the Boston Society of Architects and as an adjunct faculty with the Boston Architectural College, Rogers Williams University, and UMass Dartmouth. Blake was recently honored by the USGBC in the 2021 class of LEED Fellows. Welcome, Blake. Glad to have you today. Jacob Knowles is the Director of Sustainable Design at BR+A. Inspired by his leadership and vision, BR+A has championed millions of square feet of zero net energy buildings and carbon neutral campuses, resulting in numerous grants and awards, including 3 AIA COAT Top 10 awards. Most recently, Jacob has advised Boston and the state of Massachusetts in the development of zero carbon zoning and a net zero stretch code so that all future buildings will be carbon neutral. That is good and noble work for sure. Thanks for that and welcome, Jacob. Alejandra Menchaca is a vice president in the sustainability practice for Thornton Tomasetti. She combines expertise in mechanical engineering and building science to give clients a clear understanding of the impact design strategies and innovative solutions have on long-term building performance. That's the what's in it for me calculation and assessment, right, Ale? She is experienced in the design of both passive buildings and energy and carbon intensive structures, such as labs and healthcare facilities. Her expertise also includes thermal comfort, energy modeling, daylighting, embodied carbon, and computational fluid dynamics. Ale holds a PhD from MIT in mechanical engineering and has taught courses on natural ventilation and energy buildings at both MIT and Harvard GSD. Welcome, Ale. Really excited to have you as part of our panel today. So we have an esteemed panel, and it's important and I think helpful that we do, because this is not an easy topic. The PH role in the building boom of life sciences and biolab facilities takes some thought. And we'd like to start with Wolfgang, if you'd like to maybe take over and screen share at this point, because we want to bring this all to light in talking about a specific project, and particularly a project that has received pilot certification from Passive House Institute. So Wolfgang, if you would take over and just kind of give us an overview of the project and some of the key opportunities and challenges, that'd be great as a place to start.
Yes, thank you, Beth. Thanks for the great introduction, and I'm honored to be here. I can share some experience from this project, which we have done about 10 years ago in Saxony. Those were 2 laboratory buildings for agricultural research, so biolabs in that sense. And the third structure is purely administration and office. You see the scale, it's about 5,000 square meters, so it's large enough at least to prove that this is possible. And we had to find strategies how to implement passive house approaches in the laboratory context, which meant that we designed a fabric that was very much oriented on the normal passive house practices appropriate for the cool temperate climate in which we were designing. And it is clear for passive house laboratory buildings that the fabric will be the element that outlasts many, many changes that can be expected in the course of a laboratory usage. Equipment changes frequently, research topics change and require different equipment. So there's a lot of fluctuation and changes the norm rather than the exception. The fabric design can be done with the PHVP, really straightforward, if you base your design on a low internal heat gain scenario. And this means that you assume the lowest internal heat gain usage that is to be expected with reasonable caution in the lifetime of the building. So the fabric will accommodate this. And still perform as a passive house and still provide all comfortable interior surface temperatures in the winter, and with all the passive house elements like passive house windows, etc. So we will not require any additional heaters or some other complications for thermal comfort, which in turn makes the usage of the space very flexible. And the fabric as such can remain in use for a very, very, very long time. Good air tightness is another element that also interacts with the ventilation system. And since we have high ventilation flows in intensive usage scenarios, a very good degree of air tightness is really important to force the air along the path we want it to have. And of course, the cooling design must use the opposite scenario with high internal heat gains, so we can design systems that are capable of handling those. And this is a very, very short outline. Of course, I could talk for a long time on this, but I think we will clarify more elements in the course of the discussion. Yes, so that far for an introduction.
Was this building, Wolfgang, all electric, or did you have a combination of?
It was not all electric. It was based on a combined heat and power approach that the client wanted at that time. It uses concrete core activation, so already has very low flow temperatures for heating and cooling, and could be switched to a heat pump system very, very easily. So it really, from the design standpoint, doesn't make much of a difference. So irrespective of the challenges of this use type, you think it would have been, had the owner wanted all electric, you don't think there would have been any technical hurdles to getting there? Absolutely no. They had this idea of using biomass fueled combined heat and power, which has its own virtues. But given the limited availability of biomass, in the future, the all-electric approach will be more probable and more viable for the majority of cases. So I'd like to kind of transition the conversation, Jacob, over to you. And as Wolfgang kind of laid out this particular application, would the approaches taken in this project, would they be easily adaptable to kind of what we see here in the US in terms of the boom in building and especially in the area of speculative building? How do you feel about, kind of what you've heard so far?
Yeah, I think there's a great opportunity here and a great challenge at the same time. So the bio building boom is huge. I mean, our firm alone is working on tens of millions of square feet of core and shell developer lab buildings in Boston, New York, San Diego. I mean, in Philly, it's all over. Boston is one of the big epicenters right now. We're working on about 25 million square feet of corn shell labs in Boston alone. It is wild. So these buildings are going to be around for a long time. They're going to consume a lot of energy. Even the best ones are going to consume energy, and they're going to have a big carbon footprint. So how do we do better, right? We don't want just a lab building that's, you know, only moving towards an electric source and then just buying an enormous amount of renewable energy, right? All those things still have environmental impacts. So passive house really should be the future of all buildings, because it starts with these really aggressive load reduction and efficiency measures before you then try to offset with renewables. That really should be the last step. So this has absolutely got to be part of the solution. And, you know, the housing market is going that way. Basically, zero carbon zoning in Boston is expecting passive house or nearly passive house level of buildings. The next version of the stretch code is going to be approximating passive house level of performance. So, you know, why only housing or offices? This should be applying to labs too, but therein lies the challenge, right? These labs are a totally different beast. And Wolfgang's example, you know, is somewhere in between. Maybe it's kind of a middle ground light lab, but these developer labs, they want to bring in any tenant out there in the market, right? Chemistry, vivarium, biology, you know, they want to be able to put anything they want in these buildings, and they have to supply them with all this infrastructure day one. So the tenant doesn't have to come in and build everything from scratch. They want the air handlers, they want the boiler plant, they want the chiller plant, they want all that stuff in there before they even sign an agreement to fit out their personal space. So, you know, how do you take something like a passive house level standard that's supposed to be really finely tuned and super efficient and really thinking about all the load reduction strategies and make it this incredibly flexible, one size fits all solution? I don't really know if we know the how to solve that problem yet, but we, you know, Ale and I have been working on a project where the goal was, can we achieve passive house for this big core shell developer lab? And we haven't quite solved it yet. We're working on it. The envelope is definitely a big piece of it. Really maximizing the heat recovery is a big piece of it. But if you've got these challenges, right, you've got a big central system, it's one size fits all, it's put in before you even know what the tenant is going to be. It can't use enthalpy wheels, right? Because there's all this fume hood that might go into the building. And you've got so much of the load is driven by the exhaust and makeup air that, yeah, you want a great envelope, but at a certain point, the envelope has little tiny impact, and the air handling systems have a huge impact on driving energy and load. So how do we fix this, right? That is our challenge.
So let me move over to Blake and ask a question about the relationship between developer and tenant. I know you've talked a lot about the role and the necessity of green leases. So how do you think about that on this type of project? As Jacob said, there are great challenges, but there are great opportunities too. So how does the idea of a green lease play into, you know, some of those opportunities?
That's a great question. So, you know, the reality of this, you know, it's interesting to hear Jacob paint a picture of the desires of our clients, and the desires of our clients are infinite flexibility. And it's true, we hear it on our end as well. And we're also working on tens of millions of square feet of commercial speculative office lab. And I qualify that statement as office lab because we like to design the buildings to be infinitely flexible as a lab. But the reality is that only 30 to 40% of a speculative office lab building will be lab. The rest of it will be a building that will be load driven and can benefit from all the, you know, when we talk about passive house, we tend to just focus on energy and all the technical aspects of the balancing of the energy budget, so to speak. But there's so many other myriad benefits of passive house, such as increased resiliency, increased durability of the building, reduce noise levels, particularly in urban areas, because we're starting to put office lab buildings in places where they traditionally wouldn't go, near highways and communities. So there's a lot of benefits to getting the envelope right, because the reality of the situation is that it won't be 100% lab, even though we design the buildings to have that potential capacity. And so if we can utilize the tenant guidelines, design and construction guidelines, and what we might call or refer to as a green lease to put budgets on ventilation, plug loads, maybe even design the building with special zones that can have that infinite flexibility. And then the rest of the building performs more like an office building. And you tighten those areas within reason so that we're not limiting vast swathes of the market to be able to take tenancy within our buildings. Then maybe this is a strategy for how we overcome some of these challenges of the desire for infinite flexibility, but also, on the other hand, the desire for carbon neutrality within our lifetimes. So that's a way that we're starting to see clients to overcome this in the office market. And in Canada, we've got speculative office buildings, not office lab buildings, but speculative office buildings that are carbon positive because of the utilization of these green leases. And so it's really just a matter of figuring out how to factor that into an office lab market.
Yeah, and if I may add, I think that there's two things that come to mind. One is we're definitely, by the current building boom is leading to a lot of buildings that, because of this argument that labs, the envelope doesn't matter that much in labs from a performance standpoint, then we're starting to see lots of glass and lots of very high performing elements to the envelope, which has a very significant impact on comfort, both visual and thermal comfort on the occupants, right? And so regardless of what the use is for the building, if you walk past labs in lab intensive areas, if you walk past Cambridge, for instance, you'll look up and you'll see all these glassy buildings where, there's people have blocked off, the glass, just so that the glare is not that uncomfortable. They put cabinets against the glass, right? There's visual impacts as well. But just from a practical standpoint, poorly performing envelopes are typically related to very glassy areas and workspaces, and spaces where lab work requires so much focus that you really need to provide an environment that is visually pleasing and visually conducing to high performance work, as well as, a thermally comfortable space. You don't want people to feel too cold or too hot, depending on the season. The other thought that I have to Jacob's point is I agree that we are designing that clients want all this flexibility, right? And so sure, you could have a vivarium in each one of your floors, right? But how many of your buildings actually have a vivarium in each one of their floors, right? And what is the reality? I've worked on buildings that have been designed to be labs, have all the systems in for labs, and at the very last minute, the tenant pulled out and it became an office building, right? And so at that moment, yes, in theory, the ventilation air, if we were operating the space as a lab, that part of the ventilation air would perhaps be dominant, and so the envelope would not have that much of an impact. But much more often than not, we see that the spaces end up having much fewer loads, right? And Jacob, you have great examples of labs that you worked on where, you designed the loads that are ridiculously high, and in reality, the actual equipment load is really, really, really low, right? And so we over design, but then, the reality is that we're not necessarily seeing those loads, seeing those ventilations. And so the reality is that if we looked at practice, at what's actually happening and not what we're designing for, we would see that the envelope probably matters much more in a good 90% of the buildings that we build and redesign than what we look at from a design standpoint. It's important to keep in mind how the space will actually be occupied.
So I want to flip back to Wolfgang, because I think, Wolfgang, you would agree with Ale that the envelope, the role of the envelope is forever, right? So how do you think about it from a PHI standpoint or from a practitioner standpoint, a building science expert? Talk to us about your point of view on the role of the envelope.
Yes, as I remarked before, the envelope is what remains in place for the lifetime of the building and is hardly altered underway, no matter how the usage changes. That's one thing. And the other thing is that I perfectly agree with Ali that visual comfort as well as thermal comfort is really the objective of building the building in the first place. It is a shell which should separate us from what's happening outdoors. And hence, we should design it for good daylighting, for example, but not to overheat. It's not to be a crystal palace. And that will make managing the whole building much easier. So a fenestration of about 40% of the facade with lintel-free windows to allow light in, but a parapet under the window. I mean, this part doesn't contribute to lighting in any way. And also this psychological aspect. I really share this, Ale, that yes, being productive in an intellectual way, you need to feel secure, you need to feel well, not only thermally, but also space-wise. So yes, the fabric matters much, and this includes the fenestration for daylighting, but also solar control, so a shading element, which still will allow daylight in, and all those things. That's very established passive house practice, and I don't think we must discuss it in a lab-specific way.
So Jacob, let me flip back to you and carry this conversation a little further. You know, clean rooms presented different types of building challenges back in the day too, when people tried to figure out how to ring fence the needs of a clean room. And it's not entirely a perfect corollary, but from a design standpoint, is there any thought to a building within a building? Like, is there any thought to creating like the space that's necessary for the needs of a laboratory environment, or even a data room for that matter, within interior to a building, to allow the design of the rest of the building to bring all of the extra benefits that we know are important from an overall occupant health and well-being standpoint, not having to give those up? Is there any room for that kind of conversation, or is the purpose of this building so prolific that it's the whole thing is a lab, although or a major piece of it is a lab, that it just doesn't make any sense to do that? How do you feel from a design standpoint?
Yeah, so I wouldn't necessarily recommend trying to pull the lab away from the perimeter. I think in a lot of ways, the lab, because it has minimum ventilation rates, is a great type of space to absorb some of those envelope loads, right? Because you have to move the air through there anyway. Might as well use it to cool it when the sun's coming in, or heat it when it's winter time. So I don't necessarily think you want to pull it away from the facade, but you definitely want to tune the facade to minimize those loads and think about orientation and potential program that's going to be in there. But the biggest challenge in my mind is, you know, when a developer's building a core and shell lab, they often don't have any idea who's going in there. It may be a single tenant's going to take the whole building. Of course, that's their dream scenario, right? But oftentimes it's multiple tenants. You could have 10 different tenants in a building. So you could get to the last tenant and say, well, we designated this half of the building to be labs and this half of the building to be office. And you've now leased 90% of the building, and there's one space left, and somebody wants to come in and use it for chemistry. And you say, oh, you know, sorry, take a hike. That part of the building only has air for office use. You know, that's going to be a tough case to make to the developer, to limit their options for who they can lease to. And then the other thing is, a lot of you know, bio startups are like an incubator, right? And they're going to grow and expand. So they might have one floor day one, but their goal may be to have 3 or 4 floors within the next few years as they ramp up their research and production. And if you've said to them, look, we can't accommodate your growth, they're going to go lease from somebody else's building so that they can grow in the future. So the research really has to drive these decisions. So that's a problem, right? We design buildings that are from start to finish. We know exactly what's going to happen in them. They're going to be that way for at least 20 years. And absolutely, we use enthalpy wheels. We use the most efficient systems. We tune all the air to just the right amount. Absolutely, we do that. But when it comes to a core and shell lab, ooh, that is tough. And so the thing that we're trying to tackle on our end is, okay, if we have to have this super flexible ventilation air system, how do we make that as ultra efficient as possible while not having any cross contamination, so you can still put fume hood exhaust through it? And one of the things that we've innovated on is tying heat pumps into the exhaust heat recovery system. Now, it's an active system. Obviously, it's not as passive as a purely passive wheel or fixed plate heat recovery. It's going to actively use heat pumps to pull that heat out. But if you can basically neutralize that load and use a very efficient heat pump to move heat from the exhaust into the supply, maybe that is one strategy that's part of our tool set to help solve this problem for these big lab buildings. you can basically neutralize that ventilation load with its own energy source from the exhaust, pull that heat out of the exhaust, maybe that's part of our solution to this problem.
Have you also, while we're talking about just design in general, on some of the projects that you're working on, do you also loop in, controls vendors into conversations around on demand, how to automate the controls in a manner that help you with that flexibility?
Oh yeah, absolutely. Blake brought up a great point, which is the idea of a green lease. Or even if you don't call it that, at least putting into the lease agreement very clear directions on what the expectations are for the fit out. We are absolutely doing that. That's a huge value to add to the client and to the tenant and to achieve these low energy goals, because you're not saying you can't do X. You're just saying, well, if you're not doing X, if you're doing something less, use less, right? You can set up a whole series of logic in your lease to say, here are the expectations and limits in all of these different scenarios. We want you to match your ventilation load to your minimum air change rate for health and safety or fume hood driven exhaust. We want you to match your load with a hydronic system, like a fan coil unit or a chilled beam, so that you're only heating and cooling as much as you need and not pushing more ventilation air to handle a load in the space. There's a lot of strategies in there that we try to use to kind of set limits and goals within that framework, but it's still flexible enough that when they really need that chemistry lab, they can put the air in there that they need.
So Ale, pivoting off of what Jacob just said, as you're thinking about the building that you guys are working on, are there other elements specifically from an occupant benefit standpoint that you think from a tenant standpoint, you would want to make sure were included in a green lease?
That's a good question. I think that if the envelope is well designed from a comfort standpoint, then ideally you should be set. I mean, the design should accommodate for enhanced control techniques for glare and for thermal comfort, of course. Discussing, having a discussion around thermal comfort and how that is to be managed is important. But I think that as long as if we start off with an envelope that is solid and that is just, is good enough, then is stellar, let's put it that way, then you really don't have to worry about so many other things. You really don't need to make the lease even more complicated than that. I don't know if Blake or Jacob, you can think of anything else that I'm not thinking about.
Yeah, Blake, I was going to flip over to you on that too, so please jump in.
Sure. Yeah. To chime in on this idea of utilizing the lease as the mechanism by which to control the runaway flexibility theme is another thing that researchers don't like to do typically, particularly in that sort of startup growth space that we're starting to see take off and fuel the market here in the Boston metro area. Most of them don't do facilities. They don't have, they're not in construction. They're not in construction management. They're not in facilities management per se. They're usually figuring things out as they go. And it could be an opportunity for the more sophisticated clients to be able to say, look, we offer a service of where we design build as well. So you come to us with a need and we'll build a suit for you specifically. That was the way that the particular project I was talking about, which is, again, it's an office building. It's 104,000 square feet in Waterloo, Ontario. It's a project called Evolve One. The client utilized a green lease in order to fit all the potential tenants within the bounds of the building's ability to power itself on a carbon neutral basis. And that's been verified performance since 2018. So if we started building to suit, then that would probably take a burden off of our potential tenants, just so that they could come into the space, grow as needed, and work within the confines of the lease. And as Ali said, keep it very simple, as opposed to them trying to figure out how to make all these complicated metrics. Again, I think that to reinforce the overall theme of this conversation is if we have a very tight, very well-designed thermal envelope, then we can do that. If we just say the envelope doesn't matter in a full lab scenario and we toss it out, then we set ourselves up for well, for not success with regards to this. So I think that if we can keep it simple and we can maybe make our tenants' lives easier by building to suit, and continuing that relationship with the core shell team all the way through to the fit out. I think that's another opportunity that I see, is that we tend to just focus on these buildings from the core and the shell, and then and even the municipalities have overarch in terms of the performance and verifying various different case studies and things like that whenever we're doing the core and the shell. But that monster tenant that Jacob talked about, that is the client's dream, that comes in and takes 100% of the leasable space, there's no oversight on behalf of local municipalities to make them do anything other than code compliance. And therein lies the problem, is that the tenants can fit out 200,000 square feet and it just meet code, whereas the core and shell building was designed for a lot more efficiency. So I think if we can start to sort of close that gap, then we can start to really, create a market for the green leases and maybe the build to suit.
That's a great point. And I'll transition, Wolfgang, back to you in terms of what you're seeing in Germany and in other parts of the world when it comes to these types of buildings. Are they mostly build to suit, or are they as speculative as we have here in the States? And are there pressures from municipalities in other parts of the world? Do you see the same pressures that we're seeing here to drive to things like electrification and decarbonization?
The projects I've been in touch with were rather more specific, really. So, but within this specificity, whatever, it is clear, as I said, that even the specific user will change their habits within a decade or two. So still the same rule applies. The fabric will stay in place, and almost anything else is subject to change. I would like to also respond to Blake and Jacob, because I think Blake's argument that the most frequent actual usages differ from the very high demand scenario. You should also make an economic argument for a somewhat boiled down solution that can accommodate usages up to a certain threshold, not in an unlimited way. And honestly, nothing is unlimited. So everything has its limits. It's just what limit we can communicate and what we design for. And the more specific we can be, the more optimized solutions we can come up with. That's plain. And besides, if we have a good fabric, then heating loads will always be very low. So even in a low load scenario, office-like, we can easily provide this with the ventilation air. And if we have the plant to accommodate more intensive usages, we can, even in that scenario, use it to cover somewhat higher cooling demand in the summer. So this won't hurt very much. And I think that's an economic benefit from this passive house approach, to come up with a plant that can handle almost everything with the ventilation system alone.
So Jacob, take that and make that a little bit more local. So let's boil that down to Massachusetts. I know Massachusetts is focused on driving electrification. And as you work on your projects, is that an overarching goal for you in terms of these laboratory projects, and specifically the one that you and Ali are working together on? Is that a major driver, and how difficult is that for you to adapt? Or do you feel similarly to Wolfgang that there's almost no technical or strategic reason why you can't electrify these buildings?
Yeah, it all comes down to money, right? You can electrify anything if you want to spend enough, but obviously the smarter way to do it is to use this more passive approach, right? Do a great envelope, do top of the line energy recovery on your ventilation system, bring all those loads down, and then make a much smaller electric heat pump plant. And that is going to cost a lot less to build. And, we've been doing that across, many projects now, both ahead of the codes and now along with the codes and zoning that are coming into effect that are pushing this. we're finding a clear relationship between the amount of heat pumps that you install, the efficiency of the systems and the load reduction strategies that you use, and how that compares to conventional design, as well as the peak kind of worst case load, right? So worst case load for a lab building could be anywhere from 50 to 80 BTUs per hour per square foot for your winter heating load. But that's based on a 0-degree design condition, which happens very rarely. You're also going to size your heating plant just in case part of your heat recovery fails. You know, you can still heat the building even if some of that heat recovery is not working. And then you're going to have a +1 boiler on top of that, just in case one of the boilers isn't working too. So that might be fine in terms of sizing your boiler plant as an emergency backup, peak system. And luckily, boilers themselves are not that expensive. But now when you're trying to size your heat pumps, we're spending millions of dollars on individual projects just on the heat pumps, right? So if you now go to a full capacity, worst case failure mode, now you're spending $6 million instead of $3 million. So we've actually found that at around the 50% mark relative to the overall boiler plant, typically you can size your heat pumps for about 50% of that plant, and that'll handle almost all of your electric heating throughout the year. So you'll use almost zero gas, even though it's half the size of your boiler plant, because it's all that extra boiler plant's just for the what if scenario. So I think Wolfgang is right on with, we are oversizing systems. Let's oversize certain things as a backup, and let's right size things that we really want to run and be super efficient and cost effective.
Have you, to this point, or do you plan to, at BR+A, do any type of case study on exactly what you just talked about in terms of how you might size things in order to get the most flexibility, the most benefit with the least amount of system?
Yeah, I don't know if I call it a case study, but we kick off every project with our major clients with that same exact storyline of saying, look, here's the whole portfolio of things we've done. You can see this trend of getting to 50% heat pumps approximately and getting all electric operation. Where on that scale do you want to be? The zoning and the codes are going to push you to here. Do you want to go further? Do you want to do the minimum? Where on that range do you want to fall? And absolutely the first step is reducing the loads as much as possible. And we show our clients trends of, look, a few years ago, we were using 2 CFM a square foot in the labs. We're using 1.5 CFM per square foot in the office. That was how much capacity everybody expected. And you can see the trend from construction starts. Here's the 10 projects that started construction in 2020, 21, 22, that are going to start in 23. And nobody's using all air in the office. That's really old school. But now there's a big trend towards using hydronic heating and cooling for the lab space too. So instead of 2 CFM a square foot, you can design for 1.5 in the lab. Now that's still gobs and gobs of capacity for flexibility, but you're being smarter and tuning the systems down to be much more efficient. Some people still want to put in let's do the 1.5, but plus a little extra, or let's leave space in the penthouse for an extra air handler. So those are smart ways to build in some flexibility without oversizing things to the extreme.
That's great. And Ali, if you have something to add to that, great. The question I wanted to pitch to you, if you add any comments to what Jacob just said, is we've kind of flitted around this idea of, what are the dominant pieces of a conversation around a biolab or a life science dedicated building. But there are all of these other elements of what Passive House enables in terms of thermal comfort, indoor air quality, lighting, acoustics. And you're probably in the best position of all of us to really put a fine point on that. What are all of the other things that we gain by maintaining that type of approach and strategy?
Yeah, and I'm going to go back to Jacob's point. It's all about the money, and all of those aspects of wellness, right? Adequate indoor air quality, enhanced indoor air quality, daylighting, good daylighting, not the bad kind, views, etc., etc. So designing a space that is consciously conceived for the human inside of it. And I loved Wolfgan's example of you would not, we're designing buildings to actually separate us to the outdoors, right? If I told a scientist, I'm going to put your fume hood outside here in the garden, good luck, right? They'd be like, no, give me a building around it. Well, then why am I just giving you thin glass around it without any other protection, right? And so we need to think about spaces that are conducive to productive work. And research has shown, and it's documented, that occupants are more productive if they are in a space that is well daylit, that has the right views, that has the right indoor air quality. And that translates directly to money. And the money we're talking about is so much more than the utilities of the building than anything else. Now, the key and the challenge with core and shell buildings is that whoever builds it is not necessarily the person who's operating it and who's cashing out on that, right? And so if you make this argument to a university or anyone else, then it might be easier, right? But you still have the arguments of leases, right? And so you can have a high, if it's a space, if I am looking as a tenant, as a potential tenant, I'm looking for a space that is going to lead to higher productivity in my occupants, I'm willing to pay a little bit more rent to get do the math of salaries. We've done it with Jacob in the past. And, just think about a 1% increase in productivity in your workforce. How much money would that equate to? And it's much more than the rent you're paying for the space, than what you're paying to put in triple pane glass, and you're paying to put in, your heat pumps, anything else. It pays off right away, right? And so wellness equals money, equals productivity, and we just need to make that calculation more accessible to everyone so that people understand. It's not that people, just people are not familiar with these numbers, but it's actual, there is a financial benefit too.
Yeah, for sure. And in fact, said another way, it's almost like passive house as an enabler. The building science around passive house as an enabler makes those things, a very efficient return on investment, right? So,
Absolutely.
I mean, the key elements of passive house are what enable acoustics and healthy air and, lighting and the rest of that. So I think that as we go as practitioners, we still have to face the challenge of convincing people that passive house is so much more expensive to build, because it just isn't. Brick doesn't know if it's in a passive house or it's in a traditional building, and a roof doesn't know if it's in one or the other. And so there's still this, kind of sense of premium. And there are some organizations like Pennsylvania Housing Finance Agency that's done a lot of work, a lot of studies on in a multifamily environment. Does it really cost any more to build a passive house? And if a team has experience, it doesn't. It comes out at parity. So, but the experience curve is legit. The experience curve is real. If you don't have experience or a project team's just coming up to speed on it, there might be some type of premium. And I think Pennsylvania Housing Finance Agency has done a really nice job kind of separating how to think about passive house and the financial pieces of passive house. But so we're kind of coming up on our time here. I wanted to transition into a last question for each of you in terms of, given everything we've discussed, if you had to offer your best advice to an owner or developer considering either, build to suit or speculative development of a biolab, what's the piece of advice you're giving them in terms of how to think about passive house? And Wolfgang, I'd like to, since we started off the conversation with you, I'd like to start this section with you also.
Well, go for it. It has been done before, so there's an example. The more specific you can be, the better. And even if you have to cover a large bandwidth of usages, then cascading systems in a way that can handle part load conditions, and maybe activating additional modules only on demand, or even installing them only on demand, may be a way to accommodate this. And your cost argument you have just mentioned should be particularly valid in the lab context for passive house, where the fabric-related cost has a smaller share than in other building types. So particularly in lab buildings, little extra spending on a better fabric shouldn't be a problem, really. It's the plant.
You're saying that it's really incremental. It's an incremental spend on a project like that. Now, Wolfgang, has PHI put together any collateral? Like, are there any case studies or white papers done yet on this particular building type from PHI or is something like that potentially coming?
Yes, it is. I have sat down and started putting together a piece for Pacipedia, which will outline the general approach how to tackle a lab project. It will be ready for the conference.
Oh, that'd be terrific. That's outstanding. So I'll flip to Jacob in terms of last comments or parting comments to our audience.
Yeah, I think passive house is absolutely the future. You know, in this wild west of carbon neutral, net zero buildings where people just, you know, throw more renewables at the problem instead of really solving the fundamental problem, which is load reduction and getting the energy demands way, way down first. We need a true North Star of something like passive house to help clarify what is truly best in class as opposed to kind of wreck purchase greenwashing. So let's get it out there. Let's make something that's viable in the market, that the market can reach for and achieve, but that really, you know, pushes the limits of what's possible.
Blake.
Well, I guess I'll have to speak from the architectural standpoint. So I think this is a design challenge. And, you know, I think that if we approach it with a level of creativity, then we can solve this problem and we can help reduce all those loads. We can help to control all the unnecessary heating and things like that. So, you know, that we always, you know, some of the challenges that we run into locally, I've tried to sort of speak universally, but I keep forgetting that this is a local event we're talking at. So we'll keep it locally, is that I often talk about the perfect passive house being a sphere because it's the least amount of perimeter enclosing the most amount of area. And unfortunately, we have every shape but 90 degrees anywhere in Boston, and we don't really live in spheres either. And so the challenge that we run into is working with this urban morphology that follows these sort of ancient cow paths and other types of things. And so we're sort of wrestling with the ideas of passive house in terms of how do we overcome the scale of these buildings? How do we keep them simple but also interesting at the scale that we're building these speculative office lab buildings? And I thought the example that Wolfgang gave earlier was really interesting because it begins to start to talk about some of the challenges that we run into. If you remember the photograph that he showed in the very opening slide where it had the lab building next to the community. And as I had alerted to earlier, we're starting to put laboratory buildings and speculative office labs into communities, and that's getting some pushback from people. And so how do we do that in a humanistic way? Now that European example is very interesting to me because it harkens of the adaptive comfort theory, and those geometries of those 3 bar buildings that are side by side are very indicative of what passive design has been for centuries, based on these SIBSI guidelines and these building geometries that enable passive daylighting and passive ventilation. Can we design office lab buildings to do the same at the scale that we're building them right now? Well, I look at it as a design challenge. I look at the ability to put as much rooftop solar onto buildings. And I'm not a huge proponent of building integrated PV for a whole slew of reasons that we won't get into today. But can we put a cap on a building? Yes. Can we make it beautiful, ornamental, architectural, celebratory of what it's trying to do by promoting on-site renewables? Yes. They tend to be add-ons. And one of the things that I think that's really great about pulling together a passive house methodology for core and shell buildings is that when I was first introduced to passive house back in 2007, I thought it was fantastic because instead of throwing darts at all the sustainable design options and then modeling them to see where we got better as a percentage better than code, it was prescriptive. It was an all or nothing system that was predicated on the science. And if we as a profession can begin working within that as a bit of a limit, then I think that innovation and creativity will reign forth from it.
Great, Ali, your final comments for our audience.
All right, I'm left with the last. I think I want to reinforce the thought that there is a very strong financial argument to go for passive house for a whole set of reasons. If you want a speedy approval process with the city, you want to make the city happy, the city will be happy with a good envelope because it's a good investment for the city. The city knows that a good envelope means that whatever that building becomes in the next 50 years, 60 years, it will have a good basis. You will have, your tenants, your potential tenants, you can talk to them about how the space you're creating is going to be conducive to higher productivity. And that is, again, it's a win-win, right? And so we just need to help our clients craft that argument and help them just jump into it, because they'll realize that there is money that we're just not seeing, but there's huge financial benefit to it. So it's definitely not a burden. It's been done before, and there are no reasons to try it.
So thank you all very much for joining this panel. Our experts have spoken. There are a few key themes that have come across clearly in this conversation. The first being that this is not only a great opportunity, there are some challenges. There are great challenges associated with thinking about this particular building type. Also, what we heard is that green leases are essential. We have to think about the components of green leases, and maybe there's even some work to do as a community of practitioners as we think about the components, the really important components of a green lease. What is that, and how do we help developers and owners become much more comfortable bringing forward the idea of a green lease to accommodate uses to a certain level, or just make sure everybody understands what the rules of the game are in a particular building. And then I think we heard that passive house envelopes are a no regrets move. Whether we're talking about just efficiency first and the efficiency first model, the natural order sustainability, however you want to think about it, it's almost a no regrets move. And I thought, Jacob, the term you used of the true North Star in this kind of crazy, wild world of decarbonization and energy, and also occupant health and well-being, we get all of those things. Ali, I thought you put a really nice punctuation point on the key important ingredients of occupant health, well-being, and productivity, and how important that is as we think about our buildings going forward. So I'm really excited about today's conversation. Can't wait to bring it forward and keep this all going, and would look forward to any opportunity to have a panel discussion with this group of experts. You all were terrific, and I thank you very much for your time today. Thanks for joining us. Stick with us, because we're going to get into a live discussion here that's going to be worthwhile, so hang with us. But to the panelists, thank you very much. There are two pieces of just how this works that I want you to be aware of. You can either put a question in the chat, or you can just put open your mic up and ask a question. I'm told that we can just start a conversation with all of the participants at any point in time. So you're welcome to open up your mic, just put your own question forward. But I'll go back to some of what was in the conversation that we just had, and that is around the idea of biolabs being an opportunity and a challenge. And I think the real beefy conversation took place kind of at a granular level, Wolfgang, about systems and selection of systems. And you and a few of the participants were having a conversation about the choice of systems. Maybe you could kind of just summarize your point of view on that.
Yes, well, we have seen that the bandwidth of usages is so wide, and we cannot really pinpoint what will happen in day-to-day practice. So we need to have systems that are very flexible, that can adapt to very different usage scenarios. And of course, in the first place, they need to reflect the requirements of this lab space. And particularly that relates to the degree of hazardous substances in extract air we have to expect, because those will decide whether we can use a plate heat recovery system, or if we have to revert to a runaround loop, which is inferior in terms of thermal efficiency. So that makes a big difference. And as long as we can get away with this passive plate heat recovery, then we should prefer this path, of course. If we cannot get along without the runaround loop, then the combination with the exhaust air heat pump is a smart approach to come up with an acceptable result, much better than what is normal.
So irrespective of choices on the active systems, whether it was in your comments or Jacob's or Blake's or even Ollie's, you guys all kind of agreed on this notion that the envelope's worth it. And we get that from a lot of different points of view. So, Wolfgang, again, if you just kind of kick that off, and then we'll flip over to Jacob for your comments too on, why is the envelope worth fighting for?
Yes, the envelope is the structure and the fabric of the building. So the building per se is largely the envelope, and we need to build the envelope. We cannot leave it out, no matter what loads or flows we assume. And incrementally improving the fabric that we need anyway can be done at marginal cost, more or less. So specifically with large structures and large areas of uniform design, this can be achieved very, very cost effectively. And it gives an economic insurance that this building, this structure will be useful for a long, long, long time, no matter if the Biolab boom might end in 15 years or so. The fabric will still be there and it will still pay dividends to whoever spend money on building it. So,
Jacob?
I actually think Ale made a great point about why the envelope really matters. And there's so much more to it than just loads or energy savings. There's comfort, both in terms of glare and thermal comfort. There's a whole productivity and wellness aspect to the envelope that people tend to think, oh, it's just what you see, that kind of picture of all glass. Everybody loves to just look out across the city from an all glass facade. But when you really fit out the space and you have desks and trash cans and file cabinets and people's coats and bags, and you start looking at where the envelope really performs well and how to design it to really relate to the people that are in the space on a daily basis, it's a very different thing. And so that the passive approach to the envelope achieves so many goals, acoustic, thermal, visual, peak load, energy, all of these things. So, it's part of that integrated approach to a truly high performance building that makes a lot of sense to me.
Blake, did you want to add any comments from your perspective?
Yeah, I think Ali made another good point in the presentation where she was talking about the return on investment for investing in the envelope. I think this came to the forefront in 2016 with the launch of the well building standard and Fitwell, and it was sort of like, aha, wait a minute, buildings are for people. They're not for all these other goals. I mean, they're part of the goals as well, but we designed the built environment for human usage, and human optimization should be sort of the highest thing that we're striving for. I think the challenge with that has always been the ability to demonstrate said return on investment. A building with an energy model can easily do that. It's difficult when you start getting into people because they change, they move about. If you move into a new office space or an office lab building like the ones that we've been talking about here, there's usually a pretty high amount of churn that happens with that growth or that movement. It's very difficult to measure it. So I think that we have to, as a profession, to continue to look for opportunities to find ways of measuring it, but there's not as straightforward a pathway as there is for the energy and utility resources in a building to measure that return on investment for the myriad benefits of the envelope beyond energy conservation, which is noise reduction and productivity and presenteeism and all those other types of things that those types of standards have been really pushing in the industry's consciousness.
So I think the only other area that really got a lot of, interface with our participants was around the idea of green leases. And there were some links put in by Joelle. She had some links to green lease leaders and mygreenlab.org that all had some really interesting thoughts around a green lease. In fact, the green lease leaders had a library of information. Have any of you looked at that or used any of those tools? Blake, have you saw those?
We have not. Yeah, we have not. We traditionally leverage, a lot of our work locally, since this is a local event. And thanks for the reminder, my old self. is that Article 37 and lead equivalency is really the tool that we've been utilizing. So one of the components of the core shell building in lead is tenant design and construction guidelines. And within the tenant design and construction guidelines, you can set metrics for ventilation and lighting power density and even water use and VOCs and a series of other types of things to ensure that the measures that you're putting into place for the core and the shell building are followed through by the tenants, which is something that isn't necessarily required of whenever they go to fit out their spaces. And there's a difference between Article 37 and just code compliance. And so that tool for us has been the mechanism to sort of get green lease language built into a fit out. And again, it's difficult to follow through on that because we're usually gone when the tenants start coming in. So it's something that we hope is being used and leveraged, but it's not packed in a steel case, so to speak.
Yeah, that's really helpful. And then Ollie, maybe a question for you and Wolfgang in terms of our other cities around the world. Have you seen in some of the work that you've done, other cities around the world really going aggressively after zero carbon? Some of the participants in the chat jumped back in and said, hey, Boulder, Minneapolis, Seattle, DC. The question was, is it coming to most major cities? How would you answer that question, Ollie, from your point of view?
Yes. So most major and smaller cities are defining carbon neutrality goals. And along those carbon neutrality goals, they're developing plans, and the plans, of course, involve having a net zero carbon built environment. There is really no achieving net zero carbon without a net zero carbon built environment. And so we're definitely seeing a push for a better envelope, for higher efficiency systems, and just for strategies that make sense from an energy recovery standpoint. Making sure that we're using the energy, only the energy we need to make spaces conducive for a productive work environment or living environment and other building typologies without necessarily wasting any resources.
On that, if I may chime in on that note too, I think it's really interesting to see how Passive House specifically is being leveraged in Canada as a means by which cities like Vancouver, I believe Toronto is following a similar trajectory by allowing development, because they realize the development companies need to really drive this home. And so they're allowing height restrictions and additional zoning and additional FAR for Passive House certification on projects. And so I think that that's really becoming a game changer, just because when, we're asking for a lot of investment up front for these better envelopes, better systems, fully electric buildings. And if we're able to work with the development community to say, hey, well, we're going to ask for this additional money, but you're going to make it back even quicker because we'll give you these sort of allowances that you wouldn't be given if you were just meeting code compliance, then that's really how it's begun to take off, at least up there. I imagine we could follow something similar down here. But I know that specifically in Boston, additional height is always a point of contention.
Yes, there's another aspect that carbon emissions are increasingly price tagged. So there's a negative incentive. Also, not only positive incentives for extra zoning, but also an incentive to avoid carbon emissions related cost. And generally, we are moving towards a renewable energy system. And the Passive House Institute has developed the PER rating system just to accommodate this, to make the right decisions today for buildings that will perform well in an all renewable energy system of the future. And as such, there's absolutely a mega trend to electrify buildings, because electricity is what renewable energy systems yield. And this is our primary energy. That's why the role and the factoring of electricity in a renewable scenario changes fundamentally from what we have been used to in the past.
Well, that fits very much with what Wolfgang Feist said in his opening comments, right? In terms of natural gas, there's nothing natural about natural gas, right? I mean, that's kind of what you're saying, Wolfgang. Anyhow, well, if anybody has any closing comments after we've gone through our whole process of the videos and the live Q&A, if anybody has any parting comments, I'll start with Blake. Your microphone is still open. So is there anything you'd like to add after hearing all of this and seeing some of the questions and issues in the chat? What would your parting comments be?
Yeah, I think, again, we've said it all here before. I think that, Passive House is here to stay. It's having a moment, and it's been having a moment for about the past 3 years. And just, again, this is a really exciting design time and design opportunity that the profession needs to, really begin to just get with the program and keep pushing it forward.
That's great. Ali, what about you?
I think it's all been said. Thank you very much for attending and listening to us. And please reach out to us. We're all very passionate about the subject. We've had really interesting conversations about it that make us go one way and the other. And we have, we play devil's advocate very frequently. And so we would love to do that with you as well. And so please reach out to any of us if you have any further comments or discussion.
Yeah, that's a great point. Craig said in his opening comments that, this is such a generous community. We don't want people learning things twice. Like if we learn, then we should be teaching so we can accelerate this pace of the learning curve for those who come after us. So it is a very giving community in that regard. Thanks for pointing that out, Ali. Wolfgang, anything to end with?
Yes, I would underline this very much. We need data. We need evidence-based decisions. We need monitoring, particularly on buildings like those, where the usages are the major unknown, really, and to be better able to judge what a laboratory of this type, for example, is. It is good to have monitored data on energy use, on occupation times, on all those variables that affect the system's design very much.
That's a great point, Wolfgang. We talked about this as we were preparing for this session, right? The idea of measurement and verification wasn't so interesting to people because Passive House, and the power of Passive House is that you should be able to tell just by looking at your energy bills, right? Like what additional measurement verification do we really need? But we've come a long way since then in terms of, occupant health matters. Indoor air quality, particulates matter, acoustics matters, as does delineating energy use and how can we learn in a more finite way where our energy is being consumed and where it's coming from, even electron by electron, right? So anyhow, I appreciate all those comments. You guys were world-class, absolutely stellar, and appreciate your engagement, preparation, and being available to do this live Q&A also. So slides live, I think we're out. You can close us out.